Okay, this is the second video for chapter 7, which is Relier Proportionality et Fonction Linéaire. Before we continue with the topic, let's just have a look at the assignment I gave you in the last video. I asked you to identify certain linear functions from 9 functions that I gave, and I asked you which of these were linear functions. So let's go through them one by one. This is the first one, f of x is equal to 4x squared. This is not a linear function. A couple of you did say that this was a linear function. That is wrong. This is not a linear function because a linear function has the format f of x is equal to a into x, where a is a given number. Here it is 4 into x squared. So this is not a linear function. Similarly, this one, every one of you got this right. F of x is equal to 4x squared plus 4x. Obviously, this is not a linear function. It is not in that format. Number 3. Okay, so number 3, fx is equal to minus 4x. This is a linear function because basically you're multiplying minus 4 into x. So same format as there. F of x is equal to a into x. So this is a linear function. Then number 4, f of x is equal to 0. Yes, this is a linear function because we already saw this. This I already explained to you, because it can be written as it can be written as 0 into x, and anything into 0 is 0. So this is also a linear function. Now we come to number 5. Number 5 is a linear function because x over 4 can be written as 1 over 4 into x. This is a. So this is a linear function. Number 6, some of you said this was a linear function. It is not a linear function because it is 4 over x. It's not 4 multiplied by x. So if you have 4 into 1 over x, this is not a linear function. Number 7, it was very simple. X into 2300, which is the same as 2300 into x. It is a linear function. Number 8 was f of x is equal to 2400. There was no x on the right side. This is not a linear function. That's a cross. It's not an x. Okay, number 8. Sorry, that was number 8. Number 9, which none of you got right, I'm a little disappointed in that, was f of x is equal to minus x. It is a linear function because it is equal to minus 1 into x. A is, in this case, is equal to minus 1. Okay, now we start on the actual topic of this video. Just let me turn the page properly, and we have this here. Representing a linear function by a graph. So we have done this. I've given you functions, and you have drawn the graph that represents that function. But representing a linear function by a graph is very, very simple. A linear function is always represented by a straight line passing through the origin. So this is always true, that a linear function, whatever be the value of a, is always a straight line which passes through the origin. What is the origin? Where the x-axis and y-axis cut. Now this is a statement which can actually be proven, but I won't give you the proof because we don't know enough at this stage to be able to understand the proof. You can either do it through trigonometry, or you can do it through theorem de Thales, which is later in this book. It's in English, it's known as Thales's theorem of proportionality. Okay, so now we see this is what a linear function looks like. You have the x-axis and the y-axis, where we mark the f of x. We take the x here. This is a straight line passing through the origin will represent f of x is equal to ax. Whether this line is going like this or in this direction depends on the value of a, but it will always be a straight line going through the origin. And now you realize why it is called a linear function. Linear meaning in a straight line. So linear function, it is called this because when you represent it on a graph, you get a straight line. Okay, so let's take a particular function. Let's take this function f of x is equal to 2x. So if we write down a few values, minus 1, f of x will be minus 2, 0 will be 0, 1 will be 2, 4 will be 8. We are just doubling whatever value we put for x, we double it. So here, as I wrote before also, x we are just multiplying by 2. So now if we try to draw this, we can plot these 4 points and then see how the curve looks through them. So let's do that here. And so 0 gives us 0. Let's start with the first point. The first point is minus 1 gives us minus 2. So that is this point here, x is equal to minus 1. It gives us the output of minus 2. The second point is 0 gives us 0 because double of 0 is 0. So that is the second point. Okay. Third point is if we take 1, we get a double of 1 is 2. So we take 1, we get 2. And the fourth point is, I chose a rather wrong value, 4 gives us 8, we take 4 and this gives us 8. This would be 8 here. Okay. Now if you join all these points, you will get a straight line. So this is the graph that represents this function f of x is equal to 2x. So essentially, because you know it's a straight line, you only need to find out one point, any one point, because you know that it goes through the origin. So you just put a scale at, suppose we had calculated that point, we put a scale from there to there and we just draw a straight line. So since a linear function is represented by a straight line and it passes through the origin, we need to calculate only one point from the formula. So let's take that. Let's take an example of f of x is equal to 0.5x. This is also a linear function. A is equal to 0.5. So here, or 0.5, instead of saying, we could have said x over 2. So if we draw a table, let's take only one point. When x is equal to 6, f of x is equal to 3. Yes, 6 into 0.5 gives us 3. So let's plot that. We draw this 6, we mark it as 3, so we mark that point and then we put a scale and we draw this straight line, because we also know that when x is 0, f of x is 0. 0 into 0.5 will give us 0. So instead of calculating a number of points here and joining the curve, we just need to calculate one point and we just join it through the origin and we draw the straight line with a ruler, with the scale. So this line for a function, now I draw a general case where we don't know the value of a. So if this is x, when we take a value of 1 for x here, if f of x is equal to ax, if x is 1, then f of x is equal to a, correct? A into x, x is 1, so it becomes a. So this is the general case of the line. You take 1 here, you mark out a there, whatever a is, and then you just draw a line through those 2 points. So this line for a function f of x is equal to ax passes through 0, 0. This is this point 0, 0. You know what this means, no? 0 value x, 0 value on the y-axis, and 1 a, 1 on the x-axis and a on the y-axis, and you just draw this. here I explain it again. F of x is equal to a into x. Therefore, f of 1 is equal to a into 1 is equal to a. So if in any linear function, f of 1 will equal a. So here if we had gone and if we had taken this linear function, if we had tried to find out for 1, what would it be? F of 1 would equal 0.5 into 1, it would equal 0.5. And if we come down here, if we see there, f of 1 is, let me hold that with the other hand, f of 1 is here, which is actually 0.5. We could have taken this point and joined the line. Normally we take a little bit further away from the origin so that we don't make mistake in drawing the line. Okay. So now, if we have two functions, two linear functions, I'm always talking about linear functions now. Let's take two linear functions. If we have two linear functions, f of x is equal to 0.5x and another one, t of x is equal to 2x. Remember, both of these are linear functions. So, if we plot them, you will see, let's take the first one, f of x is equal to 0.5x. So when x is equal to 1, f of x is equal to 0.5. So we can mark that point and we can draw a straight line, and this is the line we get for f of x is equal to 0.5x. We take that function t of x is equal to 2x, and here when x is equal to 1, the y value or the f of x, the t of x value in this case is equal to 2. So I get two lines. So I'm marking this is my f of x is equal to 0.5x. That one is t of x is equal to 2x. So I'm drawing two linear functions on the same graph, and you can see here the bigger the value of a, this one a is 2, here a is 0.5. So the bigger the value of a, the steeper is the slope. So it is 2x. This one was 0.5x. If I had a third function which said z of x is equal to 3x, that would be even steeper. It would be to the right of this line, it would be even steeper. If I had one f of x is equal to, or z of x is equal to 0.1x, that would be a line which would go like this. So the bigger the value of a, the more steep it becomes, the line. This is, you can just observe this yourself. By the way, again I'm talking quite fast. You can pause and slow down and rewind if you don't understand anything, if you want to repeat something. And also YouTube allows you to watch videos at slow speed. If you go to the bottom right and you choose the settings thing, I think it looks like a gear, and you can choose the playback speed. You can choose say 0.5, which is half speed, or 0.75, which is 3/4 speed. My voice will sound just a little bit different, but it will be usable. Okay, so here we have the bigger the value of a, the steeper is the line. This is what I have just said. Now we go down. The value of a determines the slope of the line. So how steep it is, that's called the slope. Indeed, in English, a is in fact called the slope of the line representing f of x is equal to a into x. So in English, a is called the slope of the line. Later on, if you know trigonometry, you could even find out from a, you can find out the angle, the actual angle it makes with the horizontal line, with the x-axis. Okay, in French, because French, as you know, will use more complicated terms. In French, a is called le coefficient directeur de la droite. Le coefficient directeur. Remember this, because this chapter will use this often. And by the way, this is all explained on page 100 of the book. You can read it. If you forget the term, you can go there and read it. A is le coefficient directeur. Okay, now let's look at a few special cases. or not special cases. Let's see, if a is 0, the line slopes like this. If a is, what did I say? If a is greater than 0, the line slopes like this. Okay, it climbs. It goes from left bottom to right top. The higher the a, the steeper it is. That we just saw. Okay, that is one case. Now, if a is less than 0, the line descends. It goes like this. For example, let's take an example. If f of x is equal to minus x, remember this is a linear function where a is equal to minus 1. If we try to draw this, if you just plot a few values, if you make a table, you don't need to take even 3 points. We could have done with just 1 point, but we can just do, for sake of clarification, if x is equal to 5, f of x is equal to minus 5. Yeah, you see there, f of x is equal to minus x. If x is equal to 2, you get f of x is equal to minus 2. If x is equal to minus 4, you get f of x is equal to 4. If you try and plot these values, you will get this. Let's take if f of x is equal to 5. So if you say, if x is equal to 5, f of x is equal to minus 5. This is where my finger is pointing. Similarly, when x is equal to 2, f of x is equal to minus 2. When x is equal to minus 4, here f of x is equal to 4 up there. So this is the line that is drawn when a is equal to, when a is less than 0, then the line slopes from top left to bottom right. Okay. Now we have one very special case. What happens if a is equal to 0? If a is equal to 0, then f of x is equal to 0. What does this show us? That in this case, for all values of x, f of x is equal to 0. The output is 0 if any value of x you put 10, you put 20, you put minus 6 million, you'll always get 0 here. So just to make it clear, if I write the table f of x and I put certain numbers, f of x, the output is always going to equal 0. So how do we draw this line? Well, since the output is always going to equal 0, on the y-axis 0 is there. So this line is actually on top of the x-axis. So you see, this line went like this, this line went like this. This line, when a is equal to 0, this is a very special case, just goes horizontally on the origin. That is, if this is the 0 point, it just goes like that. In French, la droite est confondue avec l'axe des abscisses. Okay, so now I will stop here. There is no assignment with this, not even a simple one with this video. And next video we will take up the concept of proportionality, and then we will see how proportionality is linked to a linear function. And once we do that, we can start doing the problems very fast. We will do these are very, very simple problems, because basically they involve either calculating a or drawing the line. It's very simple, it's always a straight line, and other problems which also you will find simple. So I stop this video here and just watch this. I will tell you when through WhatsApp before when I want you to finish watching it, and after you watch it, I will post another video probably tomorrow on the concept of proportionality. Okay, that's enough for today. It's almost 20 minutes now. Please go back and watch it again, this video. Slow it down. If you like, pause, rewind. You have to understand these concepts before we can do the problems in this chapter. Okay, bye.